Okay, everybody, welcome back to Chapter 10, Part 2. Nice to talk to you. This is what we did last time. We looked at linear regression and the equations for linear regression. So what we're going to do today is we're going to practice this, make sure that we are all clear about what to do, and then we are going to talk about just some small concepts at the end. So first, let's do some practice. How many variables do you use in a linear regression? How many variables are used in a linear regression? The answer is 2. 2, the same as a Pearson's R, right? We had Pearson's R was two variables. Same thing with a linear regression. Those two variables must both be continuous. They must both be continuous variables. You cannot do a linear regression with categorical variables. You shouldn't anyway. Don't even try it, right? Okay, well then, isn't that the same as a Pearson's R? Don't we use two continuous variables in a Pearson's R? What's the difference between linear regression and a Pearson's R? The difference is that linear regression is unstandardized. Whenever I'm going to give you a linear regression, I will tell you the exact amount of x, and I want you to predict an exact amount of y. Always. But in Pearson's R, it's what is the relationship between these two variables overall? The number, in Pearson's R, remember, Pearson's R can be anything from a -1 to a 1. That number represents the relationship between those variables in standardized units. Remember, we actually transformed them into z-scores, right? And we used that. That is the difference. Pearson's R is standardized. Linear regression is unstandardized. You know you have a linear regression if I give you an exact value of x and ask for an exact value of y. When I'm doing that, I want the value of y to be in y units. So what do I mean by that? Well, let's do an example. How many hours of sleep do I predict if you've consumed 8 cups of coffee? Now, when you look at this, I'm asking for the exact number of hours of sleep. That's going to be y, right? I'm looking for y hat. I want the predicted number of hours of sleep. Y hat, predicted value of y. The predicted number of hours of sleep. When I have exactly 8 cups of coffee, okay? So let's go ahead and do this, starting with calculating the covariance. So go ahead and calculate the covariance between hours of sleep and cups of coffee. So to do this, we are going to look at the data that we've been looking at all semester long, right? Here they are. Hours of sleep and cups of coffee. Now remember, area code is categorical. We don't even want that. We're going to delete that. We're going to get rid of it. We don't even care about that. So what we need to do, if we're going to get the covariance, is we are going to calculate the deviations for each of these. So I'm going to create a new column right after cups of coffee and another one for sleep. Okay. And then this value right here is going to be, whoops, that's going to be the mean. I'm going to make that not quite so big. All right. This is going to be the mean for cups of coffee. So looks like I'm going to have to make this a bigger font. And I will in a second. So 2 is the average amount of cups of coffee for this particular data set. All right. Let me just make this font bigger so that we can all see what's happening. Excel wants to not work. Come back, Excel. There we go. So the mean number of cups of coffee is 2. All right. There are 1, 2, 3, 4, 5, 6, 7 people in the sample. Look over here. We know that because the participants are 7. Okay. And the average number of cups of coffee is 2. Okay. We also need the average hours of sleep. So let me just grab the average hours of sleep, 8.57. Next, we need the deviations. Remember, we're trying to get the covariance, so we need to get the deviations times the deviations. So this is deviations of coffee, and what's going to be X, so participant 1 drank 2 cups of coffee minus the mean, which is 2. So, whoops, there. The mean number of cups of coffee is 2. And guess what? 2 minus 2 is 0. We do that for everybody right there. Okay? Then we do the same thing for hours of sleep. This is going to be deviations sleep. It's going to be participant 1 is 6 hours of sleep minus the mean of 8.57 hours of sleep. And here's what we get. Six minus 8.5714 is negative 2.5714. And we get that for everybody. There it is, right there. Those are all the deviations. But remember, we actually want the product of deviations. So I'm going to insert one more variable right here. This is going to be the product of deviations, which is x times y. I'm just going to do that. X is sleep times coffee's deviations. All right, so that's going to be, for participant 1, it's 0 times negative 2.5714 is 0. And we do that for everybody. That's what we get. Okay, remember then covariance, we need to sum those up. I'm going to add all the products of the deviations. Oh, we got a 1. Yep, that's not normal that we would get a 1 exactly, but that's what we get in this particular case. However, this is not the covariance yet. Covariance is going to be the sum of those deviations divided by n minus 1. Now remember, the n, there's a total of 7 participants here, so n minus 1 is going to be 6. It's going to be 6. Covariance is 0.166666. It's 0.17, right? That's what the covariance is. Next, what is the slope? Well, if you remember, when we looked at these, the slope is going to be, come on, right there, the covariance divided by the standard deviation of x squared. Okay? That's what we're looking for the slope. That's what our estimated slope is going to be. So let's go back to our data. And for this, we're going to have to remember, gosh, what was x and what was y? What was x and what was y? Now remember, x is the thing that I give you the exact amount of. Now if you remember, in the example, I gave you, whoops, that's not the right one. That was an old one. I gave you an example of, come on. If I give you exactly 8 cups of coffee, how much sleep do I predict? So that means 8 cups of coffee. 8 is the exact amount of x. So coffee is x and sleep is y. Okay, so we need to get the standard deviation of x. All right, so let's go ahead and do that before we actually get the b. So this is going to be the standard deviation of coffee. That's going to be the standard deviation of Oh, that's the deviations. I don't want that. That's not right. The standard deviation of cups of coffee is these. Let me make sure I didn't miss any. 1, 2, 3, 4, 5, 6, 7 of them. Good. So the standard deviation of cups of coffee is 1.53, roughly. All right? Well, then we need to square that. The standard deviation of cups of coffee squared. We know it's cups of coffee because that's the number I gave you. I said exactly 8 cups of coffee, right? So we're going to square this. It is this squared. We get 2.33. Now, the slope is going to be the covariance divided by the standard deviation of x squared. So our slope is going to be 0.07. 0.07. 0.07. 0.0714 is our slope. So then, how do we get out A? What is A? All right, now if you remember, A is going to be our y-intercept. It's going to be the mean of y minus the slope times the mean of x. What is x again? What is y? I don't remember. Remember, x is the thing that I give you, right? I tell you exactly what's going on. In this particular case, I said that I want to know how many hours of sleep you get if you've consumed 8 cups of coffee. I gave you 8. I gave you 8 cups of coffee. That means cups of coffee is x and sleep is y. So we're looking for the mean of y, that's the mean of sleep, minus the slope times the mean of x, and the mean of x is the mean of the cups of coffee. When we do this, then we go here. This is going to be the mean of y, remember that's the average hours of sleep, that's this right here, minus the slope, that's b right there, times the mean of x, and that's the cups of coffee right there. 8.42. So what that's saying is that if you drink 0 cups of coffee, I expect that you're sleeping 8.43 hours. That's what I would expect. Okay, if I have these, then what is y hat? Y hat is the predicted value of y. Y is sleep. Remember, I want to know if I have exactly 8 cups of coffee, how many hours of sleep do you predict I will get? Well, if I have 0 cups of coffee, you'd predict I get 8.42 hours of sleep. So let's figure this out. This is going to be the slope of the line, just like we've done before. So y equals bx plus a. So this is going to be b, it's the slope, times x. What's x? X is what I gave you. I told you in this example, I want to know what is the exact number of hours of sleep if you drink exactly 8 cups of coffee, right there, 8 cups of coffee. So x is 8, the value of x that I give you. That's the x that you put into this equation. In that case, 8 plus a, which is the y-intercept. If you drank 8 cups of coffee, I would predict you'd get 9 hours of sleep. That's what this is saying. All right, let's do another example. How much sleep do I predict you'll get if you like donuts at a level of 3? Your liking for donuts is 3. How much sleep do I think you're going to get? Okay, well, let's go through this process again. In this particular case, we have already got hours of sleep over here, but now we need donuts as well. So in this case, I said, I want to know how much sleep you're going to get if your liking for donuts is exactly a 3. In this case, sleep is going to be our y. I want to know how much sleep you're going to get. And liking for donuts is going to be the x. So let's move this over. We're going to get the same information that we've gotten all in the past. So we need the deviations. I'm gonna have to make this make this the right font size so that we can see each other. All right. So this is going to be the deviations for donuts, deviations for liking for donuts. All right, this is the deviation for liking for donuts. Well, in order to get that deviation, we better get the mean. So this is going to be the mean of liking for donuts. So the average liking for donuts is 5.43, roughly. Okay. So this is going to be the deviation. It's going to be x minus x bar. All right, there we go. And there we go. Negative 0.43. Those are all of those right there. Okay, next, to get the covariance, we need to multiply those deviations by the other deviations that we already have. So this is going to be the product of deviations. So it's going to be the deviations of sleep times the deviations for liking for donuts. We're going to get all of those. Then we're going to add them up. And we get 0.2857. But that's not the covariance yet, because covariance is going to be the sum of the product of deviations divided by n minus 1. Our n in this case is 7, so it's going to be that number divided by 6.0476, roughly 0.05. Okay, now the next step is going to get B, the slope. So what is the slope? All right, well, the slope is going to be the covariance divided by x, the standard deviation of x squared. Well, what's x again? Oh, x was liking for donuts. So the first thing we need to do, is make sure that we get the correct standard deviation. So this is going to be the standard deviation. In this case, it's a standard deviation of a sample. So make sure you remember that part. All right, that is going to be our standard deviation. And then we're going to square that. So the standard deviation of liking for donuts squared is going to be 8.257. It's roughly 8.29. All right. Okay, good. So next, then, to get the slope, we need to take the covariance divided by the standard deviation of x squared, and that is going to be, that's our slope. That's an awful slope, isn't it? 0.01 if we round up. Boy, that's a really bad slope. These are not related very well. That's what this is telling us. Okay, if our slope is 0.0057, roughly 0.01, then what is A? What is our y-intercept? Well, that's going to be the mean of y. Remember, we want to predict the number of hours of sleep. So sleep is y in this particular case. So the mean of y is that, 8.57. That's the mean of y. Okay, it's the mean of y minus b times the mean of x. I'm going to go ahead and put a parentheses there just to make sure that you know what we're doing. I don't technically need it. B times the mean of x, right there. 8.54. I expect that you're going to sleep 8.54 hours when you have zero liking for donuts. That's what that is saying. So just to kind of review where we're at so far, here's where we're at. We calculated the covariance so that we could calculate the slope. Then we calculated the y-intercept by taking the mean of sleep minus the slope times the mean of liking for donuts. And that's how we got that number. Okay, if we've got that, then what is y hat? Meaning the predicted value of y. Y is the hours of sleep. So in this particular case, we need to know what is the value of x, because y equals bx plus a, the slope of the line, just like we've always done. So in this case, we told you that how much sleep do I predict if you will get if you like donuts at a level of 3. So x is 3. I gave you x, it's 3. How much sleep do you predict I'm going to get if I like donuts at a level of 3? In this case, then we want y equals b times x. So b times 3, because I gave you 3 in the problem, plus a. Y equals bx plus a. 8.557, 8.56. I would expect you'd get about 8.56. That's pretty darn close to the average, isn't it? It's not quite there, but pretty close. So I'd expect you get 8.56 hours of sleep if you like donuts at a level of 3. All right. Back to the slides. So we practiced doing all of these. Now, instead of doing what we did, you could just take the raw scores and put them into these equations up here or down here. That's fine. It'll give you the same information. I think it's a lot easier to do it through the covariance route, just so you're aware. One thing that we did not talk about, I want to make sure that we discuss before we go any farther. I know this is based mainly off of the last chapter, but there's a separate concept called the effect size, right? Well, what we're looking at is when we look at R, remember R, Pearson's R, is standardized. It's standardized in z-scores. And so what that allows us to do is it actually gives us a proportion of variability. So if we square Pearson's R, that means that we get the proportion of variability in y that is accounted for by x. You're like, well, what are you talking about? What does that even mean? Let me just show you what I mean. If you remember, we had talked about the candy bars and stress and all that stuff. So, for example, this right here, this was the R, the correlation, the Pearson's R correlation between, let me tell you what is between weeks since your last vacation and your stress. Okay? So what it's saying is, as your weeks since your last vacation increases, this is the relationship between weeks and stress, right? So it goes up together. This R squared right here, this is the proportion of variance in stress that is accounted for by weeks without a vacation. Roughly what it's saying is about 38%, at least for this sample, about 38% of what changes your stress level can be accounted for by how long it's been since you had a vacation. So R squared is the proportion of variance in y that is accounted for by x. In this case, it's saying that about 38% of what changes your stress level is accounted for by how many weeks it's been since you had a vacation. Now that means, of course, that there's other stuff that's going to contribute to what changes your stress level. But in this case, about 48% of what changes your stress level is how long it's been since you had a vacation, at least the variance of it, right? So I need you to understand what that is, what R squared means. Okay, let's go ahead and do a couple of review questions. Which of these is true? B is true. Equation of a line can predict y hat, right? We've been doing that. That's what we've been doing all day today. The equation of a line can predict the value of y. R does not equal B. Those aren't the same because B is a slope, unstandardized slope, that whole rise over run thing. R is not that. R is the relationship between those two variables. That's R. They are not the same thing. And then C down there, R squared is the proportion of variability explained by X. R squared is that, but not R by itself. Okay? Which of these is true? Correlation doesn't equal causation. So remember how we were talking about the ideas of weeks since you had a vacation predicting your stress? Well, what's going on is I cannot say that going weeks without vacation is causing the stress. There might be other things that actually cause the stress, not just the lack of vacation. It could be other things, right? Maybe it's your love life. Maybe it's your boss. Maybe it's whatever it happens to be. But correlation does equal prediction. I can predict how stressful you are, how stressed out you are based off of how many weeks it's been since a vacation. I can predict it. But the correlation does not equal the causation. I cannot say that one thing causes the other. I can only say that they predict. So when you see prediction, often we are talking about a correlation that's going on. All right, thanks everybody.